The 29th of October 2025. Just days ago, an object from beyond our solar system reached its closest point to the Sun. NASA's telescopes went dark. Hubble couldn't see it. JWST couldn't reach it. Solar conjunction created a 3-week blackout at the worst possible moment. But backyard astronomers kept watching. And what they captured has scientists arguing over one terrifying question. Is this thing natural? Because 3i Atlas is exhibiting 8 behaviors never seen before in any comet, asteroid or space rock in human history. Nickel emission without iron, a chemical impossibility in nature. Water shooting out at distances where water should be frozen solid. A color change with no explanation in physics. And trajectory deviations that would require losing half its mass except there's no debris. For 3 weeks, only amateur telescopes watched this object during its most active period. The photos they captured, the data they recorded, it exists nowhere else. Professional astronomers are furious. Some call the amateur observations unreliable. Others are asking darker questions. What if we're not looking at a comet at all? The visitor that broke the rules. Let me show you why 3i Atlas has become the most controversial object in astronomy. This isn't just another comet passing through our solar system. It was discovered the 1st of July 2025 by the Atlas survey in Chile. The 3i designation means it's the third confirmed interstellar object ever detected after Oumuamua in 2017 and Borisov in 2019. But from the first observations, something was wrong. The object was moving at 58 km/s, faster than anything from our solar system. Its trajectory showed an eccentricity of 6.137, the highest ever recorded. It came from the galactic thick disk, estimated age 7.6 to 11 billion years old, older than Earth, possibly older than our entire solar system. But age and speed weren't the strange parts. On August 6th, the James Webb Space Telescope analyzed its composition. Dr. Martin Cordner's team found a carbon dioxide to water ratio of 8.1. Every comet in our solar system shows ratios between 0.5 and 2. Borisov. The previous interstellar comet measured 0.7. 8.1 is 4.5 to 6.1 sigma above any known comet. In statistics, that means the odds of this occurring naturally are vanishingly small. Then the Very Large Telescope in Chile detected something even stranger. 22 nickel emission lines in the spectrum. 0 iron. Here's why that's impossible. Nickel and iron form together in dying stars. They're created by the same nuclear processes. Every meteorite ever analyzed contains both. Every asteroid, every comet from our solar system. In nature, you don't get nickel without iron ever. Except here. Scientists proposed nickel tetracarbonyl sublimation, an organometallic compound that could theoretically separate nickel from iron. But nickel tetracarbonyl is a synthetic industrial chemical. It's made in factories. It's never been observed occurring naturally in space. The ALMA radio telescope array measured its position 4 arcseconds off the predicted trajectory. That's non-gravitational acceleration. Something is pushing it. To move that far off course, the object would need to eject 1/6 to 1/2 of its total mass. But there's no debris cloud, no fragmentation, no comet splitting, just smooth, impossible acceleration. Multiple solar coronagraphs captured its brightness increase near perihelion. It brightened at R75 power. Normal comets brighten at R4 power. This is almost double what physics predicts. Then it changed color from reddish to distinctly bluer than the sun. Comets don't do that. Stars change color over billions of years, not comets over a few weeks. No known chemical process explains that transformation. The Swift Observatory detected water activity at 3 astronomical units from the sun, loss rate 40 kilon per second. At 3 AU, the temperature is around 180 degrees. Water ice sublimates at 100 degrees. This water shouldn't exist. The physics doesn't work. One researcher described it as a fire hose running at full blast, where there should be nothing. 8 anomalies. Each one contradicts what we know about natural objects. Together, they form a pattern that has some scientists questioning everything. And October 29th was our one chance to watch this object up close as it reached peak activity. That's when we could have seen what's actually driving these impossible behaviors. Professional telescopes saw nothing. But amateur astronomers captured it all. What they recorded during those 3 weeks might be the most important astronomical data of the decade, or the most controversial. The blackout, October 18th to the 8th of November 2025. Solar conjunction creates a 3-week window where 3i Atlas sits too close to the Sun for safe observation. Minimum separation 2.59 degrees on October 21st. Hubble Space Telescope cannot point within 50 degrees of the Sun due to safety protocols. James Webb's sunshield configuration prevents observations near the solar direction. The Very Large Telescope in Chile has automatic shutdown protocols for solar proximity. Every major professional observatory on Earth was locked out. NASA's Mars Reconnaissance Orbiter did capture images on October 2nd from 30 million kilometers away. The high-rise camera could achieve 30 km per pixel resolution. According to some reports, those images were not immediately released to the scientific community. ESA's JUICE spacecraft observed in early November from its position near Mars, but data transmission won't complete until February 2026, 4 months from now. By then, 3i Atlas will be 400 million kilometers farther away and far less active. During the most scientifically valuable 3 weeks, when the object was experiencing peak solar heating and maximum activity, professional astronomy went dark, but amateur networks didn't stop. The Unistellar network maintained continuous coverage, observers using 3 to 4.5-inch aperture telescopes, smaller than most beginner equipment. They used image stacking, taking 50 to 100 frames per session and combining them to reduce noise, distributed across North America, Europe, Australia, South Africa, and Chile. When clouds shut down Arizona, Australia kept observing. When weather hit Europe, South American observers maintained coverage. They captured continuous photometric data, brightness measurements accurate to 0.02 magnitudes, real-time spectroscopy tracking emission lines as they changed, and they saw things that raised even more questions. On September 7th to 8th, during a lunar eclipse, Michael Jagger and Gerald Raymond were photographing the night sky from Namibia. They captured 3i Atlas with a bright green coloration. That green color comes from diatomic carbon, C2 molecules, fluorescing at 518 nanometers when energized by sunlight. But here's the problem. Earlier observations from the Gemini Observatory and professional surveys found 3i Atlas to be highly carbon depleted. It produces less than 0.09 C2 molecules for every Cn molecule. It shouldn't have enough carbon to create that green glow, but the amateur photos show it clearly. Green, bright green. Was C2 production ramping up dramatically as it approached the Sun? The timing suggests yes. The Gemini South Telescope captured the tail on August 27th. It measured 1/120th of a degree across the sky. By October, amateur observations showed the tail had grown significantly longer. Continuous light curves from amateur networks tracked brightness variations through the entire perihelion passage. The object exhibited rapid brightening exactly when professional telescopes couldn't see it. Spectroscopic data tracked the Cn band, cyanide emission, strengthening from weak in August to strong by late October. The outgassing rate accelerated. The coma expanded. The tail grew. All the chemistry, all the activity, all the behaviors that could explain the 8 anomalies. Professional telescopes missed it. Amateur networks captured everything. This data exists nowhere else. No backup, no professional archive, just amateur observations or nothing. And that's what has professional astronomers so angry. If you want to understand why this controversy is tearing astronomy apart, the fight over these observations reveals something deeper than scientific debate: the fury. In late October, during peak public interest, a YouTuber known as Dobsonian Power released images. They claimed to show structural anomalies on 3i Atlas. The images went viral. Millions of views within days. The timing was perfect. Released during the Mars flyby when media attention peaked. Also during a federal government shutdown that had silenced NASA's public communications. Professional astronomers erupted with fury. One expert posted on astronomy forums, "If you don't have a 250mm telescope, you won't see jack shit." All caps. The rage was raw and visible. Within hours, debunking articles flooded science websites. The arguments focused on physics. Diffraction limits mean small amateur telescopes cannot resolve surface details at 30 million kilometer. Critics pointed out the images were captured using solar observation equipment, heavily digitally enhanced. The website i3atlas.com published a harsh takedown. The viral telescope image shows us the limitations of amateur equipment and the dangers of overinterpretation, not hidden structures in 3i Atlas. And look, some of that criticism is valid. The Dobsonian power images were overprocessed. Digital enhancement created artifacts. Amateur telescopes do have resolution limits. But here's what's getting lost in the fury. Not all amateur observations are blurry photos from YouTubers. The Unistellar network uses calibrated photometry, standard scientific protocols. Our VSO observers have contributed over 35 million measurements to professional databases since 1911. Light curves don't require resolving surface details. You're measuring brightness over time. Spectroscopy measures wavelengths, not surface features.